Hello, friends. Welcome to Coding Garden. What you are about to watch is me attempting to solve day one, part one, and part two of Advent of Code. So Advent of Code is released every year, and basically it's a coding problem every day through the month of December, and the problems get released every day at midnight Eastern time. And there is a global leaderboard where everyone in the world tries to be the first to solve both parts one and part two of any given day. But all the people at the top of this list are competitive coders. It's incredibly hard to solve it as fast as they solve it. But you can do your best, and it's also it's a good opportunity to practice programming throughout the month of December. So like I said, you're about to watch me solve day one. I would recommend you try solving it yourself first before looking at my solution. And also, one of the fun things that we did was anytime someone suggested a solution, I basically said, I can't use that solution. So my solution ended up being a little bit convoluted because there were some simpler solutions that people suggested in the chat that I was like, nope, I can't solve it that way because they suggested it. So yeah, that's what you're about to watch. Hope you enjoy it. Here it is. But hello, everyone. It's good to see all your faces. Let's get into it. So if I refresh the page, we should have day one. Here we go. So every day you'll get a two-part problem. So if you click into the day, you'll see the problem, you can read it, you'll see some example input, and then you'll have a specific prompt that you need to solve for that example input. And then everyone's puzzle input is completely different. So this is the example input that I can test my code out on. And then when I'm ready, I need to run this sample input through my code. And whatever answer I get, I'm going to put into this box, and hopefully I'm right. So let's get into it. Let's read the problem and try to solve it. All right, day one, trebuchet. And I guess the other thing to mention is pretty often the problems sort of build on each other each day. I think early in the month, the problems are easier and they don't really build off each other as much. But as you go, there are some problems you really can't solve unless you've solved the previous day's problems. But here we go. Day one, trebuchet. Something is wrong with global snow production, and you've been selected to take a look. The elves have given you a map on it. They've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Collect stars by solving puzzles. Never mind. I think I do this every year. This initial description here is a descriptor of the entire Advent of Code. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. So once we complete this, we'll get part 2. Each puzzle grants 1 star. Good luck. All right, here we go. Here is the problem for today. You try to ask why they can't just use a weather machine, not powerful enough, and where they're even sending you, the sky, and why your map looks mostly blank. You sure ask a lot of questions. And hang on, did you just say the sky? Of course. Where do you think the snow comes from? When you realize that the elves are already loading you into a trebuchet. And a trebuchet is like a catapult, right? Yeah, it's like a catapult, but it has a rope that throws a thing. As they're making the final adjustments, they discover that their calibration document, your puzzle input, has been amended by a very young elf who is apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. To be completely transparent, I'm not having very good comprehension of what's happening here. Typically, what I'll do is I'll look at the puzzle input, look at what they're asking, and then kind of like figure out what they want. But let's keep reading. I think we were here. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. For example, you would get 1, 2. I see. You have to find the first and last digit in the number. So and then it would be 38, and then 1, 5, and then 7, and 7. And this is an interesting example because this only has 1 number in it. So 7 is both the first and the last number. I think this should be easy enough. For every line, we need to search from the beginning. Once we find the first number, we're done. We then search from the end. Once we find the first number, we're done. Smack them together. We have each line, and then we need to add them all together to get the total sum. All right, so let's solve our problem. This is going to be our example input, and I'll show you kind of how I like to set these things up. So I have a day one folder. I like to create an example text file. This will be the input, and then I'm going to write some JavaScript code that reads this file in. That way, whenever I create my input file, all I have to do is change the name, and it will immediately solve the problem for this puzzle input here. So this is my full puzzle input. I'm going to grab that, put that in here. We're going to solve it on the example input first, and then we'll run our full input through it. You'll notice that I removed the new line. You got to be careful of that. And there's no new line in this one either. Okay, so first step, we need to read in the example file. I'll be honest, this is the first time I'm coding anything in over a month and a half, basically since the last time I live streamed. So we'll see how fluent I am in all of this. So I'm going to import fs from fs, which is our file system module. And then I'm going to do read file sync. So I don't need to worry about this being asynchronous because I just need to get the input and then operate on it. So I want to read in the example .text file. And then that's going to give me back a big old block of text. We're going to split it on new lines. So that's going to give us an array of all of them. And after splitting it, I'm going to filter out any empty lines. This potentially would get rid of the... Actually, let's do this. Before splitting it, we'll trim it. This will remove any white space at the beginning and at the end, and then put it into an array. So I can call this lines, input lines. And this should be all of them. So if I did this right, if we log it out, we should see the example input. So just here in my terminal, I'll go into day one. We'll run it on our index file. If I want to use import syntax, I have to do m.js. That's fine. That's totally fine. Here's what I'm going to do. I'm going to create a package.json in the folder above it. I think this should work. And then in the package.json in the folder above it, just set type to module. And that should set it for all of my day one, day two, day three, etc., etc. All right, will this work? Trim is not a function. Why not? Oh, do I need to tell it needs to be like UTF-8 or something like that? Yeah, there we go. Okay, so my code works. I read in the example file, and then I have an array that has each line on each bit of text on a single line. Now I need to solve this problem. I'm going to create a function called part1 because there's going to be a part 2, and a lot of times it'll build off of it, or I might copy paste this and just modify a few things. So this will be part1, and basically what we need to do is we need to look at all of the lines and then get the number from the beginning and the number at the end. I think what I'll do is we'll just have I guess technically I can map it. I guess I'll map it. I'll just call this values. And so for every line in the input lines, we are going to create a value. So let's search from the beginning. And if we find a number, we'll put it into a variable. So we'll call this value. It starts off as empty string. Then we'll search from the left. So is there like a find from last? Will that work? Right up top that find last. Okay, so we can do find and we can do find last. So if we do line.find, we get each individual value inside of it, and we want the first one that is not nan. So number of v does not equal number.isNan. Is this nan? If it's not nan, we get the first, we then get the last, and then the value is going to be a number with those two things concatenated together, because these are going to be strings. So first plus last. Let's see what this does for us. So if we log out all the values, and then we call part1, I think what we might do is we'll pass in the file name. That way we can easily switch it between the example and the input. And we should be good to go. Let's see. Line.find is not a function. Oh, sure, because it's a string. So we need to split it into an array. So we can use the find function. 12, 38, 15, 77. I think we made it there. So 12, 38, 15, 77. And then we need to sum them all together. So we'll just return values.reduce. We get each value, we have the total sum, and we want to return sum plus value. And so if we then log this out, we should get 142. We do. Okay, so it worked on the example input. Let's try it on the actual input. First try. So now I'll just change this to input.text. See what we get. We get 54,951. Let's see if we did it right. Now I'll plug this in. That's the right answer, right? Okay, so let's keep moving. We'll go on to part 2 now. Okay. Your calculation isn't quite right. It looks like some of the digits are actually spelled out with letters. No! Okay. And 9 also counts as valid digits. Equipped with this new information, you need to find the real first and last digit on each line. For example, this would be 29823, or so 8312. Okay. The thing is, are we only looking for spelled out numbers? Are we skipping the single numbers entirely? So this would be 97, the third from last. No, we're accounting for all of it. So we have to account for digits and spelled out numbers. This is going to be complicated because we basically have to, I guess it's not going to be that complicated. We need to look for any one of these from the left-hand side. I guess we could use a regular expression. But all right, let's go. Let's go to part 2. Yeah. So part 2 is actually, it's not even really the same at all. The only thing that's going to change is what happens inside of here, and that's just going to be a completely different function. So we are now going to create a part 2 function and then start rewriting things. So we read the file in all the same. We'll do our part 2 output. And then for each line, we can't just find the first thing that's not a number. Let's think about this. So we could find the index of the first number and then find the index of the first thing that matches one of these based on a regular expression. Whichever index is less, we'll use that. Does that make sense? So we'll call this first number and then last number. And then let's find the first numbered word. So let's just create like a little list of words here. Number words. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I want to turn this into a regular expression. So I'm just going to join it together with a pipe. So that'll be a regular expression that checks for any one of those things. And then actually turn it into a regular expression. So I can create a new regular expression where I pass this in, which should do the job. And I want to find, okay, this is going to be tricky though, because I want to find the index of the first one. How is that going to work? If I do line dot match, replace all words to numbers and then the same as part 1. I guess, yeah, that's actually a really good solution, but I didn't come up with it. So I'm going to go my route first to try and find the first one. But yeah, that's big brain. That's genius, Mark. Good thoughts. Good brain. Okay. So yeah, there's match. I guess I could just do replace. Yeah. I mean, it's so much easier if I do the replace like Mark is saying. All right, if we split it and then I say find index. The issue is I can't split it into multiple. Let's just see what we get if I do a match. If I do a match on that regular expression and we just log it out, what will this give us? No. First is not defined. That makes sense. First number, last number. Did I do this right? We join this all together. Let me just log out this regular expression. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Line is a string. Can I do execute it on the line? I didn't switch out the input, but I think it should be the same. Oh, no, you're right. You're right. We have a different example input now. Good call. Good call. Okay. So, yeah, thanks, Phoebe. Yeah, we'll go back to doing match. All right, I'm thinking through how I'm going to do it with regular expression. It's It's going to be messy, but I think I can do it. So now, there we go. So it gives us the index of where that was found, and it only finds the first one. How can we do a regular expression searching from the end? Now I'm getting really convoluted. If we reverse our regular expression so that all the words are backwards, and we reverse our string, then it finds it from the end. Can you do a regular expression that searches from the end? Use match all to get the list of all matches and then grab the last one in the list. Yeah, that'd be a good way to do it. Prefix it with this. First number, last number. Find the furthest position and gradually back off. All right. Let's see what this gives us. Invalid regular expression. Maybe this isn't valid in JavaScript regular expressions. Yeah, we could reverse the regex and reverse the string. That's all I can think of. I think I'm going to do that. Like, here's the thing. I realize we have some really good options in the chat, but I feel like it's kind of cheating if I just go with those options. So here's what we're going to do. We are going to join this whole thing together and then split it and then reverse it and then join it. So that way it will match in reverse. Yeah, like that. And then to find the last one, we will reverse the input. Is that accurate? So the last number at index 0 is 9 on the first example input. That's correct. And then 3, 3, 4. 3, 3. Wow, okay, that works. It's really convoluted, but it works. So here we go. We'll call this the first number index. Yeah, and we're going to change this to find index instead of find. And then last number index. We're going to change this to find last index instead. And then we need the first word number index. And actually, we'll just have the first word match will be this. And the first word number index will be first word match.index. It could be null, though. So, or -1. Okay. Now we need the last one. Let's make sure we can see all of what we're doing, because this is just ridiculous. But this would be the first number in first number words regular expression. Cool. And then we also need the last one. Last word. What I call it? Just match? Yeah, match. And then this will be last word number index, which will be last word match dot index or -1. Okay. Actually, I'm not even going to do the -1 thing. I'm going to do this. Okay, so the first number will be if the first number index is less than the first word number index, and there is a first word number index. Okay, how about this? So if there is a first word number index, then we want to compare which one is lower. So we're going to do a nested ternary. We're going to say if the first number index is less than the first word index, and we don't want to check the number x, we want to check the match. If the match is not null. So if the match isn't null, then we know we have to pick one. And whichever one is less, then we want, so if the first number index is less, we want it. Otherwise, we want the first number word index. How does a ternary work? Like that. Okay. But if there was no first word match, then we just want the first number index. Okay, so this gives us the index. Oh, no. Never mind. Let's call this first number. Okay, so if there was a match, get the lesser one. And if it was first number index, just grab that from the input. So we'll say line at that. Yeah, and turn it into a number. No. Keep it a string. If it wasn't, then we do match at 0, which will we'll have to reverse it for the opposite. But we'll do first word match at 0 gives it to us, and it should be a string. And then we have to convert it back into, I realize I'm doing it in such a convoluted way, but then we're going to have to turn it back into a number. So, what fun. Okay, but let's just create a little map here to convert it all. Yeah, so yeah, you just caught on, St. Lolek, what we're going to have to do here, which is going to be tricky, but we can do it. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I want these to be strings because I need to be able to concat them together. I guess I could multiply the first one by 10. I don't know. This is getting out of hand, honestly. If my memory is correct, like this might be one of the most difficult first day advent of codes. I guess I am making it more difficult on myself because replacing all of the words with numbers would have been way easier because then my previous solution would have just worked instantly. But I made it much harder on myself, which is still, I guess it's fun to watch me do it a little bit harder. Okay, so now that we have this word map, we grab it right here. I'm out of practice too, SQL Master. It's been over a month. So first word match at 0 is going to give us this, but in this case, it's not going to be reversed. And then we need to index that into the word map. Cool. Like so. Cool. That gives us the first number. Beautiful. Now we need to do the same thing with the last number. And I think if I just replace everything with the word last, it'll just work, except we need to reverse the matched name here. And that should give us our first number and our last number. All right, first try. Nan. Let's just log our first and last number. 19, undefined, 23, 34, 47, 28, 77, nan. Great. How close are we? Should have been 29, 83, 34, 47. This is way off. Okay. Let's just focus on the first number. Let's make sure that we can get the right first number. And if we look at our example input, yeah, you spoiled the easier solution. Honestly, I don't think I've ever done that on stream before, where if somebody suggests something, I can't solve it that way. So I have to be like super original with my solutions. I kind of like it. It gives me more constraints, right? All right, we should be seeing 2, 8, 1. 2, 8, 1 should be our output here, but for whatever we're getting 1 undefined. Let's just focus on the first number here. Okay. The first number index will be, find the index of the first thing that is not a number. So this should be index 0, 1, 2, 3. This should be index 3. Let's make sure we're getting that right. Okay, first number index seems to be correct. Except when it's -1. Okay, but regardless, so we'll have to account for when it's -1. if the first word match exists and the first number index does not equal 0, does not equal -1. So if first number index equals -1, that means we didn't find one at all. So we should just go with the, we'll say if it doesn't equal -1. We're going to do a bunch of nested ternaries. This is like the worst thing ever, but do it recursively? I don't know. This is really ugly to look at. All right. If the first number index is not -1, that means we need to compare them. If we don't need to compare them, then that means the input string was all words, so we just instantly grab from our word map here. All right? If it was not -1, then that means we need to compare them. So if the first number index is less than the first word number index, then grab that number from the line. Otherwise, grab it from the word map. All right, this looks good to me. Maybe this fixes our issue. Cannot read properties of null reading 0. Let's log this out. Okay, so first number index was 3, and then we got back 1. Is that correct? No, we should be seeing 2. Let's look at our first word match as well. Oh, we're passing in the wrong regular expression. Aren't we? No. We're logging this here. Let's get rid of this. Okay, we broke our regular expression somehow. We don't need to reverse the first one. That was our issue. That was our issue. Okay. All right, we're closer. So our first number index was 3. Our first word match index was 0, so we went with 2. Beautiful. Our first number index was not found, so we went with 8. Great. Our first number index was 6. This one was 3, so we went with 1. Our first number index was 6. This one was 1, so we went with 2. Our first number index was 0. And this one was 1, so we went with the number, which is 4, not 9. Great. First number index was 8, which is greater than this, so we went with 1. 0, which is less than, so we went with 7 instead of 6. And then none. All right. Now we need to make sure that we're doing the last number correctly. So here's the thing. If this were the real world, I feel like I always have to qualify this. If this were the real world, I would put these into like reusable functions and try to make this code way cleaner and less repetitive. But I'm trying to get it done as fast as possible, so I'm not going to do that. All right. Now let's debug. All right. What else did we fix in this other one? This is the other. So yeah, I guess we learned from our mistakes here. But in the real world, if I would have refactored this into a reusable function, it would probably have fixed any issues I'm having with the second one, because now I have to fix it in 2 places. But regardless, let's see. So if the last number index isn't -1, do this. Otherwise, grab the last word match. Let's see what we're getting for the last number on each of these. Undefined. Last word match dot index, last number words, regular expression. All right, let's debug the last one now. In the same way, we have the last number index and the last word match. So we have 3 and 9. Oh, I have to reverse it. I have to reverse it. That's why it's undefined. So the last word match at 0, split it, reverse it. Join it. Again, this is why I should have put it into like a reusable reverse string function. Nice. Okay. We're finally there. So we have 291. Is that our... No, we're supposed to get 281. So we're still failing somewhere. Let's see what numbers we have. Let's see where we're messing up. All right. 29, 83, 13, 24, 47 instead of 42. So this one messed up. Or 18 instead of 14, and then 77 instead of 76. All right. So the last 3 we are messing up on. We're getting the first number right, but the last number we're getting wrong. Oh, that makes sense, because we want the index to be greater when we're looking from the end. All right, I think that did it. No, now we're off by 10. Okay. We're getting the last ones right now, but the earlier ones are wrong. So we have 21 instead of 29. We do have 83. We have 12 instead of 13. 23 instead of 24. We do have 42. We do have 14, and we do have 76. So now our code is broken for the first input here, which should be 2.9. And instead we're getting back 2.1. Let's debug those indices again, because maybe this logic is wrong. All right, so for the first one, the last number index is 3. Oh, we have to reverse the index too. Man, I really made this hard for myself. So, because the index was 0 here, we need to do, I think, length minus the found index. Length of the word minus the found index. Man. Reversing really made it hard on me. But it should be easy enough. Okay, so... All right, so if we have an index, we need to say line.length minus the index. And that will give us the proper index. 286. Oh, we're wrong again. Man. Minus 1? Length minus 1 minus the index. That's it. Okay, this is super convoluted, but it's going to work first try. Here we go. So we're getting everything right now. We're at 281, 29, 83, 13, 24, 42, 14, 76. Now let's try it on the real deal and then go cry ourselves to sleep, because that took way too long. I got it. Nice, nice. Okay. Fascinating. Now, I honestly like this premise, like the idea that if someone suggests it in the chat, I can't do it, so I have to come up with like more and more original ways of doing things. I like that. Maybe we'll keep doing that. That makes it more interesting. But yeah, we did it. Yeah. So if the answer is not correct, you get as many tries as you want. But in order to prevent like spamming and brute forcing, you will have to wait. I think if you submit it the first time and you get it wrong, you'll have to wait like 60 seconds. And then if you submit it again, you'll have to wait like 2 minutes. Like it increases the amount of time you'll have to wait in between submissions to prevent people from spamming. Cool. We did day 1. And so day 2 will be released in 24 hours, basically. how many days? So I usually do 3 or 4 days. They get exceedingly harder, and I don't necessarily want to spend hours trying to solve a problem, because sometimes it does. Like in the early days when I first started doing this, I basically got addicted to it. It was kind of bad because I would be waiting right when they would release the problem, and I would try to solve it as fast as possible. And then in the later days when it gets harder and harder, I would just spend 2-3 hours on the problem, and sometimes not even getting it right or finishing it. And so like it can definitely be a time sink. No, you can even go back to previous years. So if we look at last year, you can go back to last year, especially if you want to like practice. You can go back and see. You can even see the ones I didn't solve. So last year I got all the way to day 8-ish. I skipped to day 7. And then in 2021, I only did 2 days. In 2020, I got all the way to day 7. Yeah, it looks like I really haven't made it past day 7. I got brave in the later days here. 2019, I guess I did quite a lot. Yeah, I don't think I did it before 2019. So that's it for this Advent of Code. Thank you for watching. If you solved the problem, let me know down in the comments how you solved it. And also let me know if you're going to be doing Advent of Code this year. All right, we'll see you in the next one.